Okay, folks. Today I think it worth trying something different, and today I think I'm gonna give the first part of the lecture using the iPad because the pen works really great. Okay, so I'll show you. So the pen works very great, so I can make comments on that, and I can do whatever I want, and I'm very happy about this pen. So I will do, here's what I will do, and I will give a lecture. I think that will be much easier. So today's content we're going to talk about is the statistical process control. But I tell you one thing, this, I suppose not call it process. Okay, I erase it, okay, because that color is not highlighting enough. Now let me do this. All right, so we should use this color, okay? Right. This, I suppose not call it a process. This is actually about the quality, okay? It's about the quality of the process, okay? So we're going to talk about the quality, all right? But it's called the process control because the quality, in order to improve the quality, you're gonna do systematic things. Is you're gonna do from the beginning to the end of the entire process. You're gonna find out the problems and change it. So later on, well, because I can call it a statistical quality control. As a matter of fact, many of the references call it SQC or TQC, okay, total quality control, or total quality management, or something like that. And we call it process control because people realize later on, in order to improve the quality, you have to improve your process. So then people call it a process control. So the objective of this process control is to provide a systematic signal that assignable causes of the variation are present. So there are something we need to pay attention. So there's called assignable cause. Okay, assignable course. That means the assignable course, if you don't understand what is assignable course, you can understand this way. So assignable course is fixable. Okay, it's a fixable. Some trouble is fixable. Okay, we call it, assignable course. Okay, and there are some non-assignable course. Okay, so just give an idea. Pay attention to these words. And then we're going to talk about, the process control, okay? So in the process, the statistical process control, okay, let's minimize. So the statistical quality control is basically a way to, try to identify anything wrong, okay? All right, so basically the first point is the variability, okay? The variability is the issue. The variability is inherited in every single process, regardless if it's natural or special assignable, okay, so there's variabilities, right? There's variabilities, but pay attention to this. The variability, if it's caused by natural and common causes, that might be okay because natural, you cannot, probably you will not do that much. But if this is, if something called a special and assignable course, okay, assignable cause the variability, we're going to control it. Basic idea is we hate variability. We hate it, okay? We hate it. We just don't like variability. If there's no variability, our work will be, lots of things will be greatly simplified, and we save lots of trouble. But, the variability is everywhere, right? We have a natural maybe causes, but again, we're going to pay attention to assignable courses, right? So let's see. So what is an assignable course? Assignable course means there's something wrong, and they will lead to some unfavorable outcomes, and also it's totally fixable, avoidable. So if such as poor training, okay, or bad machinery, or a poor communication, okay? So many things, and you can fix it. Once fix it, this variation will be gone. So that's the thing, all right? So the assignable course basically tells you there's something wrong. And you can totally, well, I would not say totally, but I would say mostly eliminate them entirely, okay? So, see, I use the word eliminate, because these things cause variation, variability. Okay, these things cause variability, which is not my favorite thing. Variability is trouble. So there are some natural variations, right? And there is some, something called a natural variation. That's maybe following a probability distribution or measure of tendency. So natural variation means that's okay. Okay. So basically, if I say, hey, this is natural variation, that means, okay, what are you going to do about it? Okay. So first question is, what are you going to do about it? Okay, what are you going to do? What are you going to do about it? So it's because of the nature, and the nature variation probably will stay. Okay, will stay there, and probably the only way to improve such a natural variation is by technology. N-O-L-O-G-Y. Okay, is by technology. So when the technology improves, probably the natural variation will be in control. But basically, these are not bad things. These are not good things either. Okay, these are the things we cannot get rid of entirely. And just like you want to work very, very hard and get rid of it sometimes. No, it's not possible. So the natural variation will be here all the time. Now we have something called assignable variations. The assignable variation can be get rid of. So this is the center part of the core of this lecture. Basically, we want to get rid of the assignable variables, okay, or variations. When the assignable variation is gone, and the entire process will be way better, okay? Will be way better. We'll show you, okay? So it's called, it's also called a special case of variation. Basically, that's totally, So these variations are like the natural causes, natural variations. This one will be traced to a very specific reason. Very specific reason. Just as I said, poor training, poor machinery, poor material, poor communication, something like that, right? It causes lots of things. So the objective is to discover when the assignable causes are present. That means if we have these are bad. Okay, you can remember these are bad things. Assignable variations, these are bad things. People losing money because of that, right? Because assignable variations lead to poor quality. Okay, and that's a bad thing. Okay, bad thing. We try to identify all the assignable variations and then try to remove them, eliminate them entirely. Okay. And there may be some variations we need to incorporate, but I don't want you to focus on that part, because once the process is designed and the assignable variations basically cause lots of trouble, and that's a very bad thing. All right, so okay, let's go. Let me show you some examples. Okay, so let me show. Yeah, let's look at this example. Okay. First of all, in the SPC, okay, statistical process control, I almost say statistical quality control. Basically, I think that's the same thing, but we got to be careful about the terms. Okay. So the SPC, what do we need to do? We need a sample. Okay, and everybody understand what a sample is because the population, if you do population versus sample, okay, so basically population means everyone, and sample means just I want to find out what's happening, and sample. Okay, so sample means there is a process called sample. Sample basically means find a small but representative units to try to project something happening in the population for everybody. Okay, so this is sample. Okay, like we just have one of the political campaign just completed, and the sample is actually, the sample is actually, you can understand the polls, okay? Like public opinion polls, internal polls for election. So poll basically say, I choose a bunch of likely voters. I call them, hey, who are you going to vote? And then they tell you the question, we record it. Obviously, you do not call every single American likely voter. You will find out a good sample to represent it. So you can understand this as a poll. Now, the reason we choose a sample simply because we cannot do population, it's too expensive. We have to do a small one, but we need to draw some conclusion from it. So these are samples. Okay, sample, we can assume that's normal distribution, something like that. All right. So now, in the next several slides, I gonna tell you, in the next several slides, I'm gonna tell you, basically, some trouble. Okay, there are some illustrations such as this page or next page or something, But, for me, I would rather stop here and switch to the notes. I'm going to tell you what's happening, okay? So, all right, bear me a second. I'm going to switch to notes. Now, in the notes, I can do whatever I want. And drawing will be much better, I think. Okay, now, here. Come on. As PC, okay, and SPC. Once we have a sample, okay, once we have samples, not only one of them, so, and we should be able to find a histogram or, something like that to represent the distribution, okay? So probably histogram, okay? And we find basically from the samples, and we find a distribution, okay? It can be this guy, or it can be something like this, or something like this, all right? Whatever. So that's just, from the sample, we have that. But, if it's, first of all, assignable courses. Huh? Assignable courses? How can we possibly identify the assignable courses? Well, let's do this, okay? Assignable course basically says, look, we need to find something abnormal. Okay, abnormal. Now, if no assignable if there's no assignable courses, we can assume normal distribution. Okay, we can assume the normal distribution. So now let's do this. When we can assume the normal distribution, right? For the normal distribution, we have two parameters. We get a center is a mu, and we get a sigma, right? So this is the normal distribution. Now consider this. Consider this. All right. So the first thing I need to let you know, the first thing, okay? So what if my defect rate is high? That means consider you have a factory doing the work, the defective rate is high, okay? And, and we have you have a normal sample. What if that? So that basically says, look, I got a process, I got a factory and I got something. So what is that supposed to mean? Let me show you. Okay, now I'm going to draw a normal distribution. Okay, so the center line is mu. This is the center. Okay, well, I don't have to write it down. The center, it is, right? The bell curve or something. Okay, so, and basically in the quality control, it say, hey, this end, this end. So in this range, that means good. In here, defective. And here, right, defective. So that means here, defective, here, defective. Okay, so we just take somewhere in between. So which is fine. All right, when you design it, probably people tell you, hey, this is good a proportion. Basically I say, hey, this. However, listen, watch. I'm going to change the color, by the way. Let's see. I'm going to change the color. Probably I change it to red. Red will be fine. All right. So, okay. Now, okay. If this is your process, okay, so how can I say this? Here. So if this is, in your mind, or nominal, in other words, that you think the entire, the output of things will follow this, white color the curve. Okay, normal distribution, fine. But the process is actually in red color. So watch. Okay, so if the process is the reality. Okay, process is reality. Now, what happened if we still have a normal distribution, but I get a kind of reality like this? Watch. I still centered on the line, but you see that? This is reality. And this is nominal. That means this is supposed to be, but this is reality. So, but if people don't know, okay, I really don't know what is the reality. I just apply the nominal, assuming everybody is fine. I'm using the same rule to tell which one is defective, which one is not. Now watch. I'm going to still apply this bar. Anywhere lower than that will be defective. I'm also trying to impose this bar, in the right. Anywhere less than that will be, more than that will be defective. So let's compare this. Everybody see my point? So if you compare this shadowed area in color red and color white means if everything is, following normal, the nominal curve really well, that is the diffective rate. And obviously, if our distribution changed to something else instead of nominal, and we use the same rule to tell which parts is good, which parts are right, and then what happens is we end up with so many bad parts. And of course, my diffective rate is going to be high. Okay, so this is one thing. Okay, to recap that is actually recap that is actually is this. Let me write it out. So when the I'm going to change the color. Okay, when defective is high, it means your output is not following the nominal distribution anymore. Right? It's not following the normal the normal distribution any longer. So here's the deal, all right? So you're not following that any longer. Now I'm going to draw again. So basically, here's what's happening. All right. Okay. All right. So if this is a nominal distribution, right? If this is a nominal distribution, right? So, and your real distribution is this. Right? And we apply the same rule. The nominal distribution, will only have this small of defects, right? And this is small of the defects. But the real distribution, it's gonna have way more large defects. You see this? These are the defects. So we need to find out, okay? So basically this point is over. So we need to identify assignable courses that cause the departure from nominal distributions. Okay, so this is the idea. Same idea, let me show you. Same idea is this. Now, think about that, all right? So again, I'm going to draw the line, all right? So again, this is a nominal distribution. Okay? But the real distribution changes, right? The distribution changes to somewhere else, right? The new distribution changes to here. So that means there is a shift, okay? There is a shift of center line. So that means, we're gonna change, the center line. Now, think about that. So in the older distribution, okay, so if we impose such, this part is defective, and this part is defective, and we find, these are defective. Okay, defects, right? However, if the real distribution is here, is in, the red color, right? The red color, what happens is, for this end, probably doesn't have that much, but from this end, you see? Wow, this is a giant defect. Okay? So that one causes lots of trouble too. Okay? So that basically says that's why we need to pay attention to that. The next thing is, if we have, there's many ways. But basically, the objective, remember still, everybody still remember the objective? The objective is to identify the assignable causes. Okay? So identify the assignable causes. And using a signal system. What the signal system is called? It's a kind of control charts. Okay? All right. So let me show you what the meaning of the control charts, right? Shall we? Okay. So let's find out what is a control chart. Control chart is very, 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 very straightforward. Okay, so there's nothing scientific about the control chart. Well, don't think that's a very scientific stuff, and it's a statistics, and I think everybody should be able to do it. So basically, I have a chart, and this is the time, right? And we have a different, here, these are times. You can call every hour, you can call it hour, you can call it hourly or weekly or daily or monthly. Anyway, we have the time, we can call it, period. Each period of this, right? You can call 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, I just draw 10. I don't know why. Now, here's the deal. How can we identify the assignable calls? The assignable calls will not report to you directly, by themselves. But they probably going to try something, give you some signal. How can we possibly identify the signal? Now, here's what we do. We develop two lines. We call this line is upper control limits, and this is lower control limits. And we may have a center line, okay? Center line. All right, now here's the deal. I will tell you how to construct these three things later on in the homework, but so here's what's gonna happen. All right, so now here's what's gonna happen. Now here, every time period, like time 1, I record a number. And I put these are the measures. Or you can call it, the quality measures. So each time I find a spot, okay? Something like this, it's sometimes changing, right? So if we look at all these numbers, I'll show you later on. These are samples. Okay, these are samples, right? These are samples. Okay, these are samples. Now, if the sample stay inside the range of upper control limits, lower control limits, we're good. However, if we have in 9, okay, in term 9, okay, in term 9, okay, in in 9, right? So if we observe something bad happening, this guy is from a sample, but look at this. This guy is beyond the upper control limits. Similarly, if you have something like this, it's under the lower control limits. So in these cases, 9, 10, if we have such a thing out of range, we will say there is assignable causes we need to identify. Okay, we need to identify them. All right, so everybody okay? So this is control charts. Now, how to be a good guy about control charts? You need to calculate the lower control limits, lower control limits, upper control limits, center line, and then you're gonna, we have equations on this, we have equations on this, we have equations on this. So, good news is we get everything. All right, so we should be able to calculate the control charts. Once we calculate the control charts, right? Once we calculate the control charts, we can check the samples every period. And if it's inside the range, we say, hey, we're assuming there's no or very weak assignable course. It doesn't ring a bell and not a problem. But once it's beyond or underneath the lower control limits, beyond the upper control limits, then that's clearly, these are trouble. Trouble. This is trouble. Okay? Both these are trouble. These are trouble means assignable courses. Okay? Assignable causes. So we need to find it out, right? So, I think that's pretty much of, introduction. Let me see if we can go back and use the, so look at this. So people basically need to find out what's happening here, this is the control charts, right? The control charts, if you have a control charts, at this point, here, it's out. So that means you do have some trouble, okay? All right. So this is a statistical quality control. Basically, if you identify anything here or here, that means we have some trouble either here or here. Okay, this is good. This is a good stuff. Okay, this situation is good, but other than that, this is bad. This is bad. They give you higher defect rates and poor quality over the time, okay? So we need to identify these two things, okay? So what we're gonna do next is calculate the control charts. Look at that, the control charts. I think that's very well for an introduction. Do you believe so? Okay, now, I think the talking part is over. Let's go to the homework, okay? All right.